Hey guys, welcome to the part 3 of database management system, and here we will be converting the ER diagram to relational schema. That's what we're going to do here. So for that you have to understand the ER diagram, how to draw the ER diagram very clearly. That is, you have to understand the module 1 very clearly for this concept. Okay, so I have given some previous year questions on this channel for solving this ER diagram. So to understand how you can draw a ER diagram from a question, you can go and check out that videos. Okay, or if you want a separate video for ER diagram, then please mention that in the comment section. Okay, let's see how you are going to convert this ER diagram to a relational schema. So first of all, if you have a strong entity, then how can you convert into, like, the strong entity is represented like the student is an entity, its attributes are this, and SID is the primary key. So how can you convert this to a relational schema? The strong entity can be converted just like this. Student is here. Now SID, SName, course, branch. Just the primary key has the underlining. This is how you will convert a strong entity into a relational schema. So the first thing you have understood. Now let's see if you have a composite attributes in the relational schema, like if the name has F name and L name as composite, then how can you represent it in the relational schema? How we are going to do that? So for that, if you see here, you won't represent S name, then you won't represent S name. We will only give F and L name in the schema, because it already contains the F name and L name. If you give separately, then S name will be given, will be identified for us easily, right? So in the schema, we will, if this is how our entity ER diagram looks, then we will write SID, primary key underlined, then F name, L name, course and branch. This is how we are going to write. You're not going to write S name then. Understood? Fine. Then let's see how you can represent a weak entity set. We know in a weak entity set, what happened? This is the, let's say this is the weak entity set. Fine. If this is a weak entity set, that means P number cannot uniquely identify this because it's a weak entity. It is dependent by loan, right? That means what? That means the primary key of loan should be there in the payment. That means first, loan is a strong entity, so you write it as loan number, amount, fine. But payment is a weak entity, so you write P number, P date, P amount, and you have to write the primary key of this loan also, because it, since it is a weak entity, because it cannot, this payment cannot uniquely identified by P number only. It requires loan. So we write the loan's primary key also as the payment in the payment schema. Understood? This is how you are going to represent the weak entity. Fine. Now different relationship, how you can represent many to many. Whenever many to many relationship comes, the thing that you have to very clearly understand is that in many to end relationship only, the relationship would have a table. Relationship would have a separate what I would say, many to end relationship, in the relation would have a table, like borrow would have a table which contains attributes, like the attribute from, this is the customer table, this is the loan table. Now what is in borrow, what you will write? The primary key of the customer and the primary key of the loan, both you have to write. So when it is many to end relationship, whenever it is many to end relationship, this is how you have to tell. So in many to end relationship, the primary key of customer and primary key of loan, both you have to write. This is one important thing that you have to understand here. Let's say you have many to one or one to many, represent many to one and one to relationship with total participation in relation schema. That means you have many to one some kind of relationship here. Then what you're going to do? Many to one relationship is coming, and in account section there is total participation. If in the account section is total participation is happening, that means every account branch would be there. In every account there is a branch. In every account there is a branch. That means account is totally participated in that particular relation, means every account is participated in that relationship. So that means what you have to understand, that every account will have a branch. That is what it means in total participation. So that means since every account has a branch, then you can write the branch name also for each of the account. That means the primary key of the branch would come in the account table. So those which entity type has a total relationship, that entity type, in that entity type, the primary key of the other entity type should be written. That is actually a simple meaning. You can understand it by a simple meaning. See, account is total participated in this relation account branch. That means every account has a branch. So you can give the branch name of each of the account, right? So those has total participation, then the other entity types primary key should be there in that schema. Understood? Now, so this is total participation concept is this. That is very important concept that you have to understand. Now, if you have a many to one and one to many and all, many to one, one to many, see, this is account branch. So many to one means we will take the primary key of both of this in the account branch. Similarly, if you have one to one relationship also, what you are doing, you are writing this account branch relationship and you are writing the account number and B name here. Understood? Now let's say one to one relation schema with total participation. That means, what does it mean? It is one to one relationship with total schema. We have said here many to one relationship, the many to one and one to many relationship with total participation is what we have given told here. Which has total participation, there we will write the primary key of the other. But here it is one to one relationship with total participation. That means here you have to understand, one driver owns one license is owned by one driver. That is what one to one relationship means. So what is the important thing here is that here also DID name in the driver section, this has total participation, so you have to write the primary key here, which has total participation, there you will write the primary key. Now for many to end relationship and total participation, in one to one relationship, if there is total participation in both the ends, then what you are going to do? So this you have understood, this is like many to one, one to many total participation. But here if you consider, you have total participation at both the ends. That means it will be just a single relation which contains all of these attributes, like this single relationship with all of these attributes. This much we have understood. Now here we have multi-valued attributes. Now if you have multi-valued attributes, because you have lot of phone numbers you can have, so you are not going to write in the driver schema this phone number. You will create another table for driver's phone number, which contains the phone number and the department ID as the which is the primary key from the driver's table itself. That we will write here. Understood? So let's brush out. If there is total participation, and let's brush out all the concept here. First of all, we have discussed strong entity. If I wanted to convert into strong entity, the normal case, all the attributes will be written. Then composite, I told you the composited attributes will be written here. No S name will be written. Now, how we will represent a weak entity set? In the weak entity set, we will write the primary key of the strong entity. Okay. Now, many to many relationship, I told you. In many to many relationship, we will draw a separate relationship for borrow, which contains a primary key of customer and loan. Understood? Now, total participation in many to one and one to many, or one to one also we have said. For total participation, in one side only the total participation is there. Many to one to many, and one to one. Then what we have do, which has total participation, that would contain the primary key of the other table. That is what we have said. That is what we have said here. See, this is just one to one. Yeah, here, right, the thing. But sometimes the total participation can come in both the sides. If it comes in both the sides, then that means we will create a one table which contains all the attribute of driver and license. There is no two separate table in that case. And how you represent a multi-valued attributes? Multi-valued attributes are represented by a different table, and also it contains a primary key of the, here you see DI number should be written here also, then only we can understand, oh, it's from the driver table. Understood? It's a multi-value from the driver table, then only you will be able to understand that concept there. Now let's see how we are going to, some examples are there. So these examples we'll discuss in the next part, how we are going to do this. So examples will be in the next part. Okay.